The law of cosines. So the law of cosines can be used in two cases. This is critical that you understand this, because if you don't know when it can be used, it doesn't matter if you understand the formula. So here are the two cases that it can be used. If you have two sides and the included angle, so you first of all have to know what the word included means. Remember that essentially means between. You heard this term in geometry, like with angle, side, the side had to be between. This is side, side, and the angle has to be between the two sides. All right, when you have the angle between two sides, you can find the opposite side. So here I can find AC. So if you have two sides and the included angle, I can find the opposite side, that's AC. So down here I'll be able to figure out what AC equals. The second case is if you have all three sides, you can find any angle you want. So down here, I have all three sides on the right. I can find the measure of angle A, I can find the measure of angle B, I can find the measure of angle C. Any of those work. So these are the two cases. So when you're looking at a triangle, if you have two sides and the angle between, the included angle, you can find the opposite side. If you have all three sides, you can find any angle. Remember how in law of sines we labeled our triangle. We said that angle A, capital A, opposite was lowercase a, the length, the side length. Angle B, capital B, and opposite was lowercase b, the length B, and angle C, and opposite it was C. It works exactly the same way as law of sines in the way we label our triangle. Now the formula looks a bit different. It starts off like the Pythagorean theorem. So we'll start with a squared equals b squared plus c squared. Notice though this is not a right triangle, but that should look familiar to you. And then it's minus, there's always a 2 in the formula. And then these two lengths here, it's b and c. And then cosine, the important thing here is that the cosine of the angle is opposite the side you start with, cosine of A. And if you look up in any textbook or online, you'll notice there's three versions of this formula. They'll do b squared equals a squared plus c squared minus 2ac cosine of b, and c squared equals a squared plus b squared minus 2ab cosine c. But really, there's just one case of it, and it's just a pattern. You don't need these. This is what we're looking at. And the important thing to realize is that the side you start with, in this case a squared, you end with the cosine of the angle that's opposite that side. So in this case, cosine A. So it starts off like Pythagorean theorem, a squared equals b squared plus c squared, minus 2bc, those are the lengths right here, b and c, and cosine of A, the angle opposite the side you start with. Now this works in any triangle. It does not need to be a right triangle. Here are two examples, and this is the first case. I have two sides and the included angle, the angle between the two sides. What can I do? I can find the opposite side. So in the first example, I have angle B is 85 degrees. I can find the opposite side. We'll call that B, little b. So you look at those formulas that we just talked about. As I said, it's just one formula really, and it's a pattern. So you start with the side you're looking for here, b squared equals, and then the other two sides, 75 squared plus 80 squared minus, there's always a 2 times 75 times 80, and then it's the times the cosine of the angle opposite the side you started with. So opposite little b is the angle, it's 85 degrees, angle B. The nice thing about this case, two sides and the included angle, is there's really not much work to do. You're looking for, in this case, b, and it's b squared. All I need to do is take the square root of both sides. So I'll take the square root of both sides, and then it's just a matter of punching it in the calculator. I'll show you what that looks like with Desmos. In Desmos, the first thing we have to do is go up to the tool and change it to degrees. Then when we punch this thing in, notice that I did the square root and I did a parenthesis. 75 squared plus 80 squared minus 2 times 75 times 80 times the cosine of 85. And then make sure you close your parentheses, and there's our answer right there. And we're going to round that to the 10th, so 104.8. So B equals 104.8. Another example. This time we're looking for C. So we'll start off with C squared equals the other two sides squared, 130 squared plus 130 squared. Hey, that thing's isosceles. Minus 2 times 130 times 130 cosine of the angle opposite the side we started with, in this case 76 degrees. We're finding C, so we'll just take the square root of both sides and we'll punch this in Desmos. So I put this in Desmos, and again remember that if you've done it once and haven't closed it, you should be fine. But you need to go to the tool and make sure that you're in degrees. I put in your parentheses, put in all your times marks, and there's our answer right there, 160.1. Here we have two examples of the second scenario. This is the harder of the two because you have to work some of the numbers out. You don't have any choice. And remember that when you're looking for an angle, you're going to use the inverse function. So we're going to punch in our numbers just like we did on the last couple. Remember that it is a squared equals b squared plus c squared minus 2bc cosine of a. And angle A and side A are opposite each other. So in this case, since we're going to find angle A, we're going to end with the cosine of A, which means we need to start with the opposite side, 55. So it's 55 squared equals 120 squared, the other two sides, plus 145 squared minus 2 times 120 times 145 times the cosine of A. Now we have to work these out. 55 squared is 3,025. 120 squared plus 145 squared is 35,425. 2 times 120 times 145 is 34,800. Now we need to get the cosine of A by itself. So the goal at this point is to get this by itself. That way I can take the inverse cosine and find my answer. So the next thing I need to do is subtract 35,425 from both sides. We end up with negative 32,400 equals negative 34,800 times the cosine of A. Now we'll divide both sides by negative 34,800. And we see that the cosine of A is equal to 32,400 divided by 34,800. And notice the two negatives made a positive. Now what we need to do is do the inverse cosine of 32,400 divided by 34,800, and that will give me the measure of angle A. We end up with about 21.4 degrees. One last example. So this time we're going to find angle B, and just like the last time, we start with the opposite side. So this is 120 squared equals 90 squared plus 115 squared minus 2 times 90 times 115 times the cosine of the angle opposite the 120, angle B, which is what we're looking for. So remember that the cosine of the angle and the side you start with have to be opposite of each other. So now we'll work all these numbers out. 120 squared is 14,400. 90 squared plus 115 squared is 21,325. 2 times 90 times 115 is 20,700. Now we'll subtract 21,325 from each side. We get negative 66,925 equals negative 20,700 cosine of B. We'll get the cosine of B by itself, so we'll divide both sides by negative 20,700, and we see that the cosine of B equals, and the two negatives are going to make a positive, 6,925 divided by 20,700. And we want the angle whose cosine is that ratio. And so to find an angle, we use the inverse cosine. So the inverse cosine of that ratio, 6,925 divided by 20,700. That's how we get the measure of angle B. So the measure of angle B equals 70 to the nearest tenth, 70.5 degrees.